think that foundation models are going to plateau in capabilities somewhere between where they are now and before the point at which they are very powerful and dangerous. If you figure out how human brain algorithms work and put them on a chip, then you wind up with something that can do all the things that humans and groups of humans and societies of humans can do, including inventing science and technology from scratch. If you look at the variation in human ability to do science and technology, you find wild swings from one human to another. And I definitely don't think that the best and brightest scientists and engineers are anywhere remotely close to what brain like AGI will be able to do. I think the main thing we need is motivation control, where we sculpt the AGI's motivations such that it's not like a callous sociopath that's indifferent to human welfare.
Welcome to the Future of Life Institute podcast. My name is Gus Ducker, and I'm here with Steven Byrnes. Steven, welcome to the podcast.
Thank you.
Do you want to start by introducing yourself?
I am a physicist by training. I live in Boston, Massachusetts, and I first got interested in artificial general intelligence, safety, and alignment around 2018 or 2019 as sort of a hobby in my free time. Quickly got interested in the question of what if future artificial general intelligence, AGI algorithms work in a similar way as the human brain works algorithmically. And so I sort of wound up teaching myself neuroscience at that point. And then I got a grant to do that full time in, I think, 2021. And then I was hired by the Astera Institute, a foundation in California, starting in, I think, 2022. And that's where I still am, doing mostly independent reading and research on that topic.
What's the scope of your work? What are you trying to achieve when thinking about the safety of brain-like AGI?
If you figure out how human brain algorithms work and put them on a chip, then you wind up with something that can do all the things that humans and groups of humans and societies of humans can do, including inventing science and technology from scratch, founding and running organizations, making plans. And if the plan doesn't work, then you find a way around it. If it, lacks some resource that it needs to solve a problem, then it can gather that resource. So it would be kind of more like a new intelligent species on the planet, but one that would be more numerous than humans, more experienced, that can think faster, more competent in every way. So this is sort of the setting where it sounds like wild sci-fi, which is fine because the future should sound like wild sci-fi. Heavier than air flight sounded like wild sci-fi until it happened. And yeah, so this is something that I'm expecting to happen. And this is the context where I think things like human extinction are really on the table. So I'm really interested in trying to sort of contingency plan for that and say, if people figure out how to put brain-like algorithms on computer chips that can do all these cool things that humans can do via the same kinds of algorithmic tricks, then how would we get to a good future, sort of in the broad sense? And I'm more specifically interested in mostly focused on technical parts of that, which would be like what code could one write such that the AGI winds up intrinsically either staying under human control and wanting to stay under human control, or else at least having the best interests of humans at heart, sort of as an end in itself.
So what you're trying to solve here is mostly a technical problem and not a problem of the social or governance aspects of future AI.
Yeah, I want to emphasize that those are also problems. So if we could have a plan to make AI that has humans' best interests at heart, but then the people programming AGI don't actually use that plan. Instead, they have some better idea that doesn't actually work. And then, yeah, having the technical plan was not sufficient. And likewise, it could be that lots of people have the desire and common knowledge that we should follow this plan, but over time, there's a competitive race to the bottom where the people who make, more callous, sociopathic, profit maximizing AGIs gradually make more money more fast, and they're able to outcompete the AGIs that are not like that. A lot of things can go wrong. Also, if we don't solve the technical problem, then one could reasonably say we shouldn't be making these AGIs in the first place. But again, I think having a plan, a technical plan, is an ingredient in this puzzle, and that's where my comparative advantage is. So that's what I focus on.
Do you think the current paradigm of scaling up large language models, doing these large training runs, is that inspired by the brain, or to what extent is that inspired by the brain? Do you think current progress or recent progress in AI has anything to do with us being, or computer scientists being inspired by the brain?
Well, historically, for sure, neural networks were, if I understand the history correctly, inspired by brain learning algorithms. And I think people disagree about whether they misunderstood the thing that they were trying to be inspired by. But regardless of the details, they certainly built very impressive artifacts from that. So I am part of a school of thought that I like to call a foundation model plateauists, in that we think that foundation models are going to plateau in capabilities somewhere between where they are now and before the point at which they are very powerful and dangerous. And, if you ask ChatGPT to found and run a new company and, raise it to $1 billion successful company, it's going to crash and burn. It's just not capable of that. And my guess is that that's a problem that's not, that that's, that that's a problem with foundation models as opposed to foundation models today.
Say more about that. What's the fundamental limit to foundation models?
Okay, so this is a little bit of an annoying question. It's fine that you asked it. The reason it's a little bit of an annoying question is I think we're not ready for AGI yet. I totally expect that we're going to get AGI sooner or later, for better or worse. But on the current margins, I would much prefer later to sooner. So for AGI capabilities researchers, if they're doing the wrong thing in trying to make AGI, then great. I don't want to correct them. And I certainly don't want to give them great ideas on the off chance that my ideas are in fact great and that they're listening to me, which maybe that's a little unlikely, but just in case.
So what you're saying is there could be some kind of info hazard here.
Yeah, info hazard is the term of art. Although I like to clarify that either I'm wrong, in which case there's no reason to be saying my stupid ideas on the air, or else I'm right, in which case they're info hazards. And either way, there's not much to be gained. So that's the capabilities researchers. But of course, there might also be safety researchers listening to this podcast, safety and alignment researchers. And for them, maybe, if they talk to me in person, or, I often chit chat about the limitations of foundation models to the extent that it's not giving away too many sensitive details. But I still don't feel great about, I'm not like really sold on the mission of trying to convince people to stop working on foundation model safety or foundation model AGI safety, because I think that foundation model AGI, there's no such thing, so they shouldn't be working on it. But I don't really feel great about that, because what if I'm wrong? What if foundation models do scale to AGI? I would much rather get more people to be working on brain like AGI safety by getting more people who are not already working on AGI safety in the first place, rather than parasitize from the already extraordinarily tragically small group of people who are interested in AGI safety in the first place. I don't want to be infighting like that. I think we should be doing contingency planning for both.
Yeah, yeah, that makes sense to me. Let's talk about the brain. Let's talk about differences between the brain, the human brain, and current AIs. You talk about the brain as having a learning subsystem and a steering subsystem. Maybe you can describe that.
Yeah, so I think that part of the brain is more than 90% of it, in the case of humans by volume, is running basically within lifetime learning algorithms that are sort of like randomly initialized, at least locally, in a way that's akin to machine learning algorithms, such that when you're born, your cortex, for example, is not doing anything useful. It's learning, and over time, it will become more and more useful. And in adults, it does all these impressive things like motor control and planning and language and vision and on and on. But for newborns, I think there's actually a lot of evidence that the cortex is just not yet doing really any much at all. And likewise with the striatum and cerebellum and a few other areas, and the hippocampus, which is part of the cortex. Whereas the hypothalamus and brainstem are these repositories of reflexes and innate, I like to call it business logic, which is this term from software engineering where, if, Megacorp has their proprietary code that says, if the client has, more than 100,000 euros of assets, then attach form 6432. And if the client lives in Belarus, then also attach form 9432, and on and on and on, all these really specific things that help the business run. So, by the same token, the body needs business logic. If I'm fertile, then I need to increase my sex drive. If I'm cold, then I need goosebumps. If it's time to vomit, then the way to vomit is to contract muscles A, B, and C and release hormones D, E, and F, on and on. So I think the hypothalamus and brainstem is where you find all of those things. And I call those the steering subsystem. There's nothing special about the brain, though, because if you look at any machine learning algorithm GitHub repository, you'll find lots of code that is not the core learning algorithm itself, but rather is doing, calculating the reward function in the case of RL, or doing data augmentation, calculating the loss function, all those other things. So the brain needs that too.
So, what's the relevance of learning about the brain like this, or studying the brain for creating safe AGI? Is this about you kind of front running discoveries made by others, such that we can know how to make, if it is the case that they make systems that are inspired by the brain, we have done the work of trying to figure out how to make them safe beforehand.
Yeah, that's exactly right. And I do think that there's, within the domain of understanding the brain, there's parts of that that are very important for alignment and safety, and not particularly important for making the AGI in the first place. And those are the areas that I focus on, which includes things like understanding, yeah, the hypothalamus and brainstem, and how they lead to human prosociality and norm following and compassion and things like that.
Actually, tell us about that. So, what is it that we can learn about the how prosociality relates to the human brain that's then useful for trying to make AGI safe?
Brain like AGI would be a little bit more in the camp of the kinds of reinforcement learning agents that people talked about a lot in the 2010s and have sort of fallen out of fashion in the past 5 years since foundation models came along. But so, for example, these days everybody talks about training data. In the 2010s, in the Alpha Zero era, people would talk about training environments. And that's not a huge difference in and of itself, but it's sort of indicative of this different way of thinking about things. So, in the area of reinforcement learning agents, there's the idea that you design the agent with a reward function. And I think the brain likewise has this actor critic reinforcement learning model based system. It's not exactly like any RL agent that's been invented to date, but it is something sort of in that general domain. And I do think that the brain has a reward function in the same way that AlphaZero has a reward function that says, +1 if you win the game. Well, the brain's reward function says, positive reward if you're eating when you're hungry, negative reward if somebody punches you in the face, or if you stub your toe, on and on, lots of things like that. These are sometimes called primary rewards. I sometimes call them innate drives.
Maybe you could explain the difference between trying to control AI or AGI and then trying to instill these positive social instincts. What are the pros and cons of each approach?
Joe Carl Smith has this term motivation control versus option control as sort of two ways to limit the chaos that an AGI might cause. So, option control means that even if the AGI is out to get you, it doesn't really have any options to do so. So, this includes things like putting the AGI in a box and not giving it internet access and not giving it access to actuators and stuff. It also includes things like making the AGI not terribly capable, not good at planning. Whereas motivation control would be giving the AGI, somehow sculpting it such that, building it such that it wants to do things that we want it to do. And it's trying to do things that we want it to be trying to do. And then, even if it has the option to cause harm, to start self reproducing around the internet and get out of control, it doesn't, it chooses not to. Or if it does, it does it with good ends in mind. So I think that option control is not a plan in and of itself, although it can be, an additional layer of protection. I think the main thing we need is motivation control, where we sculpt the AGI's motivations such that it's not like a callous sociopath that is indifferent to human welfare, and you ask the AGI if it has the human's best interest at heart, and it says, "Oh yes, I definitely do," but it's lying. That would be bad. Whereas a good thing would be the AGI that actually does have humans' best interest at heart. So I'm definitely in the camp of motivation control. That's what I mostly work on, and I think that a useful jumping off point would be to understand the motivation of humans, especially in those special cases where the motivation of humans is actually good as opposed to bad. So when humans are compassionate, when humans are a norm following, those are probably things that we want, or at least possibly things that seem it would be useful to know how those work. We don't necessarily want to copy them exactly, but it would be a good jumping off point.
And so the problem with trying to do option control or trying to control AI and perhaps especially AGI is that you're trying to constrain an agent that's on some quite fundamental level, perhaps working against your interests. And so it's more like trying to plug certain holes, but then problems arise at another point in the system, or some behavior of the agent you're trying to control that you don't like. And so that's a pretty difficult problem, and it's an interesting approach that we might have to consider if we don't solve the more fundamental problem of trying to align AGI before we get to AGI. But I would feel much better. I would feel much safer if we could instill the right motivations, and especially pro-social motivations into AGIs.
Yeah, that's exactly right. That we should absolutely be doing air gap sandbox tests of AGI, but there's only so many things that you can learn from some such tests.
In humans, how ancient do you think the systems that control pro-social behavior are? Because when we're talking about norm following or compassion or kind of positive emotions towards others, they seem quite complex and perhaps kind of recent in evolutionary history. What do we know about that?
Right. So I like to draw a distinction between emotion concepts versus innate drives. So emotion concepts in humans are definitely unique. They're also different in different cultures to some extent. And an emotion concept is a learned, so your learning algorithm is observing the world, but it's also observing yourself. And you can implicitly notice a pattern where you feel certain things in certain situations, and it can capture that pattern in the form of a learned concept. And that learned concept can be all the words that we use to talk about our emotions in a human context. And then a separate thing is the innate drives that are driving those, or that are sort of one ingredient out of the emotion concepts. So these are going to be more like sort of reactions or reflexes, and they're not going to be easily described in English language words. Instead, it's going to be something like when such and such, signal in the hypothalamus is active and this other signal in the hypothalamus is active, then that triggers this yet a third signal in the hypothalamus to become active. Human social instincts are definitely somewhat different from chimp social instincts. I'm not sure how much that's like tweaking the parameters on existing modules versus building wholly new modules. That's a complicated question. I think we need to know more about what these innate drives are before I'll have a strong opinion about that. One time I tried to look into whether mice and rats feel spite in the specific sense of not just like attacking a rat who's attacking them, but in the sense of using flexible motivated behavior, clearly related to reinforcement learning, to inflict harm and misery on another rat. There is evidence of this for compassion, but in my brief search, I couldn't find evidence of that for spite. So maybe mice don't feel that in the same way that humans do, but maybe they do, and I just missed it or nobody's measured it.
Yeah, it seems like a very difficult question to answer. You can't interview mice or rats, right? You can't ask them kind of complex questions. So you'd have to somehow find out looking at their behavior. Maybe there's some smart way to test this, but it seems like a difficult question to answer for me. So the purpose of investigating how prosociality works in the human brain, tell me if I'm wrong here, but is it simply that we can understand how it works in the human brain, and then maybe we can learn something about how to create pro-sociality in AI models, and how to train them in a certain way such that they develop these drives that we want them to have.
Yeah, basically. So to continue the story from before, I think the human brain has something like a reinforcement learning reward function that says yeah, pain is bad, eating when you're hungry is good, something about social drives. And by the same token, when these future AGI programmers, hopefully not too soon, invent brain like AGI, they're going to likewise have a slot in their source code that says reward function. And they get to put whatever Python code they want into that slot. One of our main technical intervention points in the motivation of the AGI is this question of what code do we want these programmers to put in that slot. So there's a lot of choices that are obviously bad. Maximize the bank account is obviously bad, but there's not really anything that's obviously good. There's a lot of things that seem like they might be good if you don't think too hard about them. But then when you look into it in detail, you find that the ultimate consequences are going to be bad. It's an open problem to have any idea of what this reward function should be. And that doesn't have to be the entirety of the plan. We also get to choose a training environment. We can also do real-time monitoring and intervention, whatever we can think of. But I do think the reward function is a giant portion of the solution and well worth investigating.
How complex can the reward function be? How much can we, so to speak, put in there?
I mean, it's just going to be some Python source code or whatever programming language we use, and it can be anything that runs fast enough and that's feasible for programmers to write and hopefully to debug, because you definitely don't want to, get the sign wrong or whatever, make a maximally bad AGI. It's certainly possible that we would want to do things like small pre-trained image classifiers. I think there's something like that in the human brain reward function. When we get vision data into our eye, it goes up to the learning within lifetime learning algorithms in the visual cortex, but a copy of that same data also goes down to the superior colliculus in the brainstem. So whereas the visual cortex just learns patterns in the data and patterns in the data, the superior colliculus in the brainstem, I think, is learning things like, it's not learning at all, but rather it's applying a lot of innate heuristics to that visual information. It's saying, is there a human face? And if so, it executes an orienting reaction that makes you look towards that human face. Is there something that seems to be moving like a slithering snake or like a scuttling spider? And if so, it implements physiological arousal. And so there's a few more things like that. And all the other senses likewise have homes in the brainstem and hypothalamus and not just in the cortex. So there's the gustatory nucleus of the medulla, which processes taste. There's the inferior colliculus, which processes sound. I certainly expect that there might be reason for programmers to put some, you can already download from GitHub, I'm sure, some face recognizer module that works just as well as the superior colliculus. It's just some tiny convolutional neural net that would work fine if that's what you were trying to do. So that might be like one of the more complicated things that people might choose to put in the reward function. And that's one of the tools in our tool belt as we try to design and solve this problem.
But if we're talking about AGI, kind of agentic, general, wouldn't we want to put something in the reward function like optimizing for compassion towards others or honesty or willingness to collaborate and all of these things? Such concepts seem incredibly complex, and it's difficult to even know where to start if we're trying to build a system that's optimizing for that.
Yeah, that's exactly right. In terms of the human brains, it doesn't understand all these concepts. It doesn't know what, peace and love is. It doesn't know who people are. It knows things like, this is vomiting and this is laughter and this is physiological arousal. So there's the neuroscience puzzle of how do we get from that kind of stuff to the empirical observed fact that humans do in fact feel motivated by compassion and justice sometimes, some humans. So that's the neuroscience question. And then in parallel, there's the AGI safety question, which is what are we going to do? So of course, we could do things that evolution could not do in our hypothalamus and brainstem. We could try to use interpretability to find the concept of human flourishing and just directly connect that to reward. And that's not a crazy plan. I happen to think it's probably not going to work, but it's not a crazy idea.
Do you think that's actually coherent to look for? Do you think, say, in the most advanced models we have today, do you think there is a concept of human flourishing? And would you be able to extract that concept and make it into the thing that the AI is optimizing for?
When you say the most advanced models today, you're probably talking about foundation models, and those definitely speak English. and therefore they at least know the words human flourishing. I'm not sure. Again, I'm not a foundation model AGI safety expert. It's not my field of expertise. So I don't really know if that concept is sufficiently, or I don't know. So like that could work. Yeah, I don't really know. In terms of an AGI, a brain like AGI, so one concern would be that it doesn't really have a concept of human flourishing as we would like it to have. It has various things adjacent to it, and it has some concept of like humans talking about human flourishing and like what they mean by that. But that's sort of not native to its ontology, but rather understood in some different sense. So, yeah, does it even have that concept in a way that would work in a sort of motivational sense? And if so, can we find it? That's an interpretability challenge. I think the cortex is learning all these concepts from scratch as patterns and patterns and patterns and sensory input. And we sort of have our work cut out in the case of a brain like AGI in figuring out exactly what's what with all the nuances. And then yet a third problem is that even if we find that concept, then the AGI is going to continue to, the brain like AGI would be continuing to learn and grow and figure new things out as it goes. So whatever so even if the concept sort of, we started out thinking that it was the right concept, the AGI comes up with new ideas and the world changes out of distribution, and maybe it's not going to generalize in a way that we like.
Do you think brain like AI would be beneficial to interpretability? Do you think it would be easier to understand what's happening inside of a brain like AI model than it is to understand what's happening inside of a modern foundation model?
Yeah, so my basic answer is it may be slightly on the margin, but not enough for it to really change much of the story. So, for example, in a brain like AGI, there would be, an actor, a critic, world model, a reward function. So you would be able to look at the operation of this AGI and you would easily be able to tell that the AGI just had a thought and that thought seemed like a bad idea, demotivating. And you know that it's a bad idea because the critic says, no, this is a bad idea. And then the AGI starts thinking about something else instead. But you don't know what that idea was or why it was a bad idea, according to the critic, because the critic is this big learned model and the world model and the actor are this big trained model. So, yeah, so it's a step in the right direction, but it's a very small step. And by the same token, if you look in the cortex, you can find some neurons in the visual cortex that are learning patterns in visual data, and you can find neurons in motor cortex that are learning patterns in motor outputs. And you can also find these other neurons that aren't in any of those categories. But you don't know what the patterns are, at least not easily. So if you say this is a high level pattern in visual input, then that's like not a huge help unless you actually know what the pattern means. And even if it's the kind of thing that you can figure out by spending 10 minutes scrutinizing all the activations and trying to shake out, like, look at different examples of what it produces, there's still the issue that are people actually going to be doing that in practice while the AGI is running at superhuman speed? Or, they could slow down the AGI, but then maybe the next company down the block is going to run theirs much faster without a human in the loop.
What are the unique safety concerns that you have with brain like AGI?
So from my perspective, I'm expecting that the way that AGI will be built is by brain-like AGI. So I don't have a clear concept of how brain-like AGI compares to some different kind of AGI, because some different kind of AGI sounds to me like square circles, and I just don't know really how to think about those clearly.
Actually, before we get there, is there a way for you to express why it is that brain like AGI is the way is the most likely way we will get AGI without putting out dangerous information?
Yeah, so one thing is, just as a sort of very, very general note, sometimes in the world, there's just kind of one best algorithm for doing something. Like fast Fourier transform is a good example. If you want to do the Fourier transform of a big data set, you should use fast Fourier transform. It was independently invented multiple times. If we ever met extraterrestrials, I would expect that they would be using fast Fourier transform as well. So that's at least a sort of vague intuition to at least raise a possibility that maybe by the same token, the brain algorithm is more or less the one right algorithm for figuring things out and getting things done in the real world. If you want something more specific, I think if you go around and ask us LLM foundation model plateauists why we are foundation model plateauists, The sort of two camps that people fall into is empirical and theoretical. So the empirical people will look at foundation models today and they'll be not very impressed by them. And then maybe they acknowledge that future foundation models are going to be better than today's foundation models, but they project that we'll run out of data, run out of compute before it really changes the story. So sometimes there's kind of stupid reasons for that, like somebody who hasn't used foundation models since 2022 and remembers them being bad and hasn't checked again since then. Sometimes there's sort of more sophisticated reasons, like picking out very specific foundation model limitations, like they do bad when there's a lot of complex stuff in a big context window. And sometimes or, just looking at the extremely bizarre ways that they sometimes mess up and frankly baffling ways that they sometimes mess up when they're also so good at so many other things, and just sort of having some intuition related to that. And then there's the theoretical people who have some grand idea about what it takes to make artificial general intelligence. And when they look at the nuts and bolts of foundation models, it's missing the right pieces or something like that. And so I'm mostly in the theoretical camp myself, although I do think there's something to that, to what I said about big complex context windows. But the nice thing about the theoretical camp is that I can make a stronger claim that I believe that not only foundation models today, but also future foundation models and even foundation models with scaffolding are still not going to, found and run a big company from scratch, that this isn't a fixable problem without a big AI paradigm shift. So that's what I believe. And I guess we'll find out one way or the other sooner or later.
Is the human brain highly optimized by evolution?
It's certainly not. I'm mostly on the no side. I mean, I guess it depends on what we're comparing to. I think the human brain is somewhat locally optimized for being a successful human, and that's very different from being optimized for science and technology and economic productivity, the kinds of things that AGIs are going to be designed for. Yeah, I mean, if you look at the variation in human ability to do science and technology, you find wild swings from one human to another. And I definitely don't think that, the best and brightest scientists and engineers are anywhere remotely close to what brain like AGI will be able to do, which is not going to be limited by head size. It's not going to be having issues with motivation and needing to take Adderall and the slow conduction velocity of neurons. Yeah, especially head size. Every time we scale up a model in machine learning, we're surprised and impressed by the new things that it can do. If you compare a convolutional neural net with 1 million parameters versus 10 million parameters, wow, it can do all these cool new things. So by the same token, the human brain is bigger than the chimp brain, and an AGI brain with 10 times more neurons. I think we're going to be very impressed by the insightful things. If you only have so many neurons, then you can't like hold a complex idea in your head all at the same time and notice the connections between different parts of it. Instead, you have to, cache it and jump around and sort of chunk it. And then you sort of miss these details. I think that that's just a limitation of our head size.
Yeah, yeah. I mean, brain-like AGI is an interesting term because when we think about what such a system would actually look like, it would surpass the brain in all kinds of ways that you just mentioned: speed, memory, just sheer size, and so on. And so, at least in some sense, it wouldn't be very much like the human brain. What is the sense in which AGI would be like the human brain?
I think there's this core algorithm that lets humans do the things they can do, like that AI can't do today. Like again, found a company from scratch and build it to $1 billion company, just as an example. And there's algorithmic tricks in the human brain that enable that to happen. So it's something, I don't know, it can find patterns and it can search through the patterns and it can compose the patterns. Whatever, it can learn the patterns, whatever we want to, however we want to think about it or describe it. And obviously, the details are mercifully not fully understood yet. But whatever those tricks are, if we understood those tricks, then we could put those same tricks on a chip. And once you do that, then we already know that scaling up a learning algorithm is straightforward. Even in the human brain, some people are missing an entire brain hemisphere and they turn out fine. You can just have the number of cortical columns or whatever be bigger or smaller. If you know what you're doing, if you understand how the algorithm works, then Scaling it up, scaling it down is straightforward. I definitely agree that in terms of the output, there are a lot of ways in which it would be radically non-human. I think it would be radically non-human in competence, specifically superhuman, and also be able to instantly copy itself and all these other things. It would also be radically non-human in motivation, unless of course we figure out how human-like motivations work and we coordinate to actually put those into AGIs successfully.
So figuring out human motivation is is the thing we need to do before we begin to, or before somebody tries to build brain-like AGI. I think it's useful for us to return to the question of motivations or human motivations for a second. Then, what are the most important motivations to understand and perhaps copy in your opinion?
Yeah, so I would just say it in a little more nuanced way, which is at the very least, we want to have a technical plan such that we can make an AGI that isn't trying to kill us before we build the AGI. And I happen to think that better understanding human innate drives seems like a useful thing to do towards solving that currently unsolved problem. But I don't have a strong opinion that it's definitely necessary, and certainly it's not sufficient. Like, even if we understand human innate drives, we still have the issue that humans grow up to be humans not only by having human innate drives, but also growing up in a human body, in a human family at human speed. And AGI is not going to have those things. So, we need to understand how these things work and take that as inspiration and jump off of those ideas. But we're still facing a blank slate engineering challenge where we get to come up with whatever solution we think is best.
Would it be something like trying to manipulate the training environment then to try to replicate what happens to humans from birth to, say, age 20?
So I don't know that that's necessary, and I hope it's not necessary because it doesn't sound very realistic. I have a strong expectation that as people approach the ability to build real deal brain like AGI, there's going to be a frantic dash of lots of people trying to scale these up in whatever way is most easily at hand. And if you have a training plan that's going to work great, but it requires 10 serial years of interacting with flesh and blood humans, then, I think human extinction is going to have already come and gone long before you finish your training plan. I think that we should be hoping that that's not necessary, but also I don't have a good plan right now, and I'm open to whatever's going to work.
I mean, in a training environment, couldn't we run at much faster speeds than say human adolescence or human childhood and adolescence? Couldn't we kind of speed run interactions with other AIs that then combined with the motivations that we have hopefully understood and copied into these systems produces something that's pro-social in a human-like way?
I definitely assume that when we know how to make brain like AGI at all, we will know how to make brain like AGI that runs at least 10 times faster than the human brain in terms of, whatever human brain thought process is happening. The AGI could think the same thing 10 times faster, not just more insightful, but also faster. So that definitely opens up an opportunity to have, an AGI. Yeah. So, it takes a human 10, 15, 20 years to be economically productive. I don't expect that it's going to be remotely that long for an AGI. If the AGI is just messing around with blocks in a virtual reality environment, certainly that can be run at high speed. If an AGI is chit chatting with other AGIs, that can also be run at fast speed. I'm not sure if that's going to be sufficient for the kind of safety and alignment that we want, because, well, it might or might not be. It depends on exactly how these innate drives work. We definitely don't want an AGI that feels warmth and compassion towards other AGIs, but not towards humans.
Yeah, I was about to say this could also be potentially counterproductive or dangerous if you're an AI, say, in an environment learning to be pro-social with other AIs. Does that exactly, when you then deploy the model, map onto the world? That's one of the tricky questions that we don't really have an answer to, I think.
Yeah, you don't want an AGI who's raised in a virtual reality environment and then sees the real world as fake, the way that we are the opposite way around. That would be another way to fail.
When doing these interviews, I've often asked my guests about honesty in AIs, because that seems to me like if we could create an honest AI, I would feel much better about the way things are going. if we could ask the model about its internal state, and it would actually give us an answer to the best of its ability. It wouldn't have to be necessarily so that it has perfect knowledge about its own internal state. But if what it's doing when you ask, what are you planning now? What are you thinking about now? If what it's doing there is an honest effort to reflect what's going on inside the model, I think that would be a pretty large step in the right direction. Do you agree with that as like a pro-social emotion that will be very valuable to replicate in AIs?
Yeah, I mean, that would be great. That's a desideratum, not a plan, but it's definitely a desideratum that I share. The reason it's tricky, or the way I think about it, is communication is a hard problem, and the way that humans communicate is they bring their whole intelligence, motivations to bear on the problem. We communicate because we want to communicate. We're thinking about how to make the other person understand us correctly.
Yeah, that's one motivation. We might also be trying to do other things. Think about sales communication. There are many types of communications, of course.
Yeah, so we're motivated to make the other person believe something that we want them to believe. And ideally, that's the truth. But if we're working through the motivation system to make communication happen, then the motivation system is also going to get all these instrumental drives like deception. So, yeah, the making an AGI that wants to be honest because we sculpted its motivations correctly is not really different from the rest of this problem of making an AGI that has motivations that we like.
How's that project going so far? How many people are working on it? Is it mostly you trying to kind of kickstart a new research direction? What, yeah, how much progress has been made in this area?
So there's a specific neuroscience research program involving reverse engineering how human social instincts work, especially involving the hypothalamus and brainstem, sort of in this framework of learning algorithms and reward functions. I obviously read lots of neuroscience literature as I work on this problem, and I'm very happy about some of the work that's been done in academia that I can cite over the years. I don't think anyone is systematically working on this problem from a neuroscience perspective apart from me right now. Or if they are, then I guess I'm not getting much useful out of. Maybe they have a sufficiently different vision from me that I'm not seeing the connection when I read their work.
I would think that it's difficult in traditional academia to frame the problem you're trying to solve the way that you're framing the problem you're trying to solve, right? It's I would guess that the work that's being done in academia is more narrow in scope and is perhaps trying to, you know, when applying for funding, people are probably not talking about artificial general intelligence, would be my guess.
Yeah, that's for sure. There's experimental measurements, for example, in the hypothalamus and brainstem that would be helpful for this research program. And people are doing those measurements bit by bit. And, you know, with a lot of luck, fingers crossed, maybe some of the connectomics groups like E11 or others could start mass producing these kinds of measurements at some point in the future. But in the meantime, there's various reasons that people are taking those measurements. And part of it is that the hypothalamus and brainstem have a lot to do with obesity, with mood disorders, with mental health. And so you can get funding that way. For example, there was a recent study where Catherine Dulac and students and collaborators found this group of cells in the hypothalamus that in rodents that sort of track loneliness and then feeling the soft touch of conspecific after a long period of isolation. And that was cool. I'm not sure how they what they put on their grant when they wanted to do that work. I don't think it's like directly solving any important. It doesn't like help me super duper directly, but it's definitely sort of inspirational and useful context as I work on this problem. So what did they put on their NIH grant for that? I don't know. It might have been something about, you know, the loneliness crisis in teens and mental health. There's a lot of things that I can imagine sort of their existing interest in.
Is there something that you would find very helpful for your work? What would make you very excited to see published by academia?
So the main thing that I'm trying to do specifically is in that project is to sort of write down pseudocode that makes sense and that's compatible with what we know about how the brain works, especially all my specific ideas about, you know, the cortex is a big learning algorithm, blah, blah, blah. actor critic reinforcement learning, write down pseudocode that's compatible with how I think the brain works, that's compatible with human behavior, that's compatible with evolution and, appropriately related to mouse behavior and things like that. And then we can sort of pat ourselves on the back and say, cool, we have at least one hypothesis that seems like it hangs together and makes sense. And then there would be an additional thing of how do we test that hypothesis? And that would come down to trying to find, I think it would be specific cell groups in the hypothalamus, probably, or less likely brainstem, that would be actually implementing the pseudocode. So I've basically been working on this problem for years, like 3 years or something, as one of the main things I've been working on. And I think I've actually made a bunch of progress recently. I have pseudocode that's probably not right in detail and certainly not covering all of human social instincts. But at least I feel like my foot is in the door now in a way that it wasn't 6 months ago. So you can read Neuroscience of Human Social Instincts, a sketch to get that sort of progress report.
We'll put it in the show notes.
I would encourage everybody else to sort of be doing that same kind of effort to come up with plausible big pictures of this kind of pseudocode and flesh out these stories. If you read that blog post, you'll find lots of open questions. And in all honesty, I don't really expect anybody to be working on those open questions except for me. But if other people start diving in, that would be delightful.
How do you verify that the pseudocode is actually implemented by the specific brain regions that you talk about? There's just a general problem of it being very difficult to understand or to verify which algorithms the brain is running.
I'll give a simpler example of laughter. And this is simpler for a number of reasons. Well, first of all, I think it's a simpler circuit. And second of all, I think it also exists in the same form in rodents and other animals, at least other mammals. I wrote this post called The Theory of Laughter last year or the year before. And it proposes that there's a specific group of cluster of cells in the hypothalamus, I think. I'm not sure exactly where it is. And I say that it should have two inputs and that it should fire when both of those inputs are present. One input would be related to physiological arousal in the sympathetic nervous system, the other to the parasympathetic nervous system. And that when both of those are present in the same time, then that should trigger this laughter reflex. So people are honing in on this cell cluster because we have already found this group of cells in the brainstem that actually triggers the motor reactions associated with laughter. So what you would do is start from there and do what's called a retrograde tracer experiment to see what upstream cell groups project to that one. And then ideally you would find hopefully a small number of candidates, and some of them would be in the hypothalamus, and you would look into them perhaps by stimulation studies or, just looking at the inputs to those. And hopefully you would find some group that's just obviously implementing the pseudocode that I wrote down in the box in that blog post. And so that would be great if somebody found something like that. I'm a little bit farther from that level of experimental readiness in the case of human social instincts or, non-laughter social instincts like compassion and spite, just because the story is a little more complicated and there's more ingredients that I'm a little bit unsure about. But presumably one could come up with exactly what you're looking for. And then, yeah, even without a dedicated experiment, if we had a connectomic data set, then somebody could dive into exactly trying to find cell groups that connect to other cell groups, or perhaps, peptide receptors or whatever that reproduce that logic in a straightforward way. And of course, I want to emphasize that the end goal is not to understand, at least my end goal is not to understand exactly how human social instincts work. I even question whether my sort of my little sketchy outline foot in the door thing might already be enough, that there's diminishing marginal returns from continuing to dive into this neuroscience question. And that's why, since writing that post, I've actually just been putting my nose back directly into the question of AGI safety and saying, okay, if that's the jumping off point, then I want to jump off of it and think, again, what reward function do we want for AGI? What training environment do we want for AGI? And it might be that after I think about that for a while, I'll decide that, yeah, I am still kind of bottlenecked by being too confused about human social instincts to think coherently about this topic, in which case I would try to flesh out the story more.
So if we were to have a good understanding of how human pro-social instincts work in the brain, how far would that take us towards solving the more perhaps important problem of AGI safety?
Yeah, I definitely don't want to make any strong statement. It seems like a useful thing to do for a bunch of different reasons. One reason is it's directly an inspiration. Another reason is it sort of helps us in this. So ultimately, we want to sort of be able to make some statement about AGI that says a reward function X plus training environment Y equals an AGI that's trying to do Z. And this is this like yet to be invented science of reinforcement learning in a brain like AGI architecture. And it would be great to ground that yet to be invented science with what happens in humans. So humans have, we know about the human training environment. If we know all of the human innate drives, then we could likewise try to relate different innate drives to where adult humans wind up in different environments. And that would be like lots of data to sort of ground our thinking and keep us on the right page in terms of yeah anticipating what could go wrong and what could go right for AGI. And then that's the sort of indirect thing, and then there's the direct thing of just being inspired by what the human brain what tricks evolution has put into the human brain and copying where applicable or modifying them where inapplicable or leaving them out when they're actually bad. There's a lot of I have a lot of concerns. Like one concern is that I feel like things like norm following and sense of justice are good, but things like social status signaling and jealousy are bad. But it might be that the very same innate drives are doing all four. Like one innate drive is upstream of all four of those different things, the good ones and the bad ones. So then we would be kind of stuck if we're trying to design our AGI to do the same, do just the good things.
Yeah, I mean, optimally, we would kind of take the best of humans and have that as our motivation for AGI. It seems like a lot of our social instincts, so not just pro-social, but social instincts, are negative and perhaps kind of concerned with things we wouldn't want future AI systems to be concerned about. Do you have a solution for the problem you just raised of perhaps some of the innate drives that underlie some pro-social motivations also underlie some negative social motivations?
I mean, if you look around at humans, some of them, yeah, hopefully they're not listening. I won't name names. Some of them just kind of suck, and others are pretty great. So evidently, there's configurations and settings that, at least in some environments, are able to output human adults who don't suck, who we're happy to have around. I'm not sure I want to make any. Not sure there's any human who I want to make dictator of the universe, and we might not have a choice because if an AGI can, instantly replicate itself and project power that way, it seems like very hard to get into a world with balance of power and things like that. So maybe we're just screwed no matter what. But at least there's a chance that some of the humans who don't suck would be trustworthy with the ability to control a large amount of power without being corrupted by it. One vision of a good future is that the AGI accumulates a lot of power and uses it to implement what's called a long reflection or coherent extrapolated volition or some other good thing that is not just like keeping the power for itself and making all the decisions, but rather taking power and using it to have some sort of more democratic and participatory regime that works out well for everybody, including the people who never signed up for this sci-fi nonsense in the first place and just want to have their good, normal human life free of disease and suffering.
You mentioned the example of CEO building a billion-dollar company from scratch. If we go back to that example, we could say that some of the traits that are necessary for such a CEO to have would be something like risk taking and ability to make decisions under extreme uncertainty, and perhaps not a willingness to endlessly debate and get feedback from others, but simply take some actions and then stick to those actions in the face of resistance also. Is there a case to be made that some of the drives that would be necessary to have capable AIs would also be potentially destructive or dangerous?
I did read somewhere, perhaps an Adam Grant book, so maybe take this with a grain of salt, but I think he listed a bunch of examples of successful CEOs and founders, ambitious people who were extremely risk averse. And so that seems to be a thing that can happen. I do think that there's 100% cases where there's a trade-off between AGI competence versus AGI safety and alignment. So one example would be curiosity drive. We find in the reinforcement learning literature that a lot of problems are better solved by an RL agent that is curious to enter novel situations. And likewise, animals and humans have an analogous curiosity drive, and presumably that convergence is because curiosity is just a good way to sort of bootstrap a learner in an environment that's too complex to learn all at once.
Yeah, I can attest to that. I had a I had my first child a year ago, and so it's been wild to see how much he's willing to sacrifice in order to try something new and to learn about his environment. Basically, at he's putting himself at risk in order to gain new information all the time. So definitely, I can attest to that.
Yeah, but if you think about a full-grown, powerful AGI, then curiosity is clearly a bad thing, because if the AGI faces a trade-off between human welfare and satisfying its own curiosity, we don't want that to be a trade-off. We want it to be all in 100% on human welfare, or welfare of animals, AGIs, or whatever else. I think there's a lot of things like that where there's sort of a more concerning one, which is that ruthless sociopaths who are willing to break the rules when they don't get caught are in practice in the world today often able to accomplish impressive things that rule followers are not and the norm followers are not. If that same dynamic holds in the AGI world, that's a really bad sign, and it's hard to see how to avoid that, or it's hard for me. Yeah.
Do you think the best way to understand pro-social drives is to look at the brain? Because it could also be to look at the environment or the culture that we are in. Perhaps when large language models are reading everything humans have ever put online, they're understanding our culture and they're understanding what it means to be honest or compassionate or rule following, such that they have those concepts. What I'm asking is whether we should look to the brain or to culture to understand pro-sociality.
I 100% agree that human social behavior depends on culture and not just on innate drives, but it depends on culture via innate drives. So this actually points to an important difference that's safety relevant between foundation models and brain-like AGI. Maybe the biggest difference is that a foundation model pre-training has this sort of magical way to transmute observations into actions. So if the foundation model during pre-training sees the letter A in a certain context, then what happens with pre-training is that turns into outputting the letter A in the same context. And likewise with every other token. There's really nothing like that in the case of the human brain. If you hear somebody say something, then that amounts to auditory expectation. Whereas if you say something yourself, that involves moving your throat and larynx and mouth to emit words. So people can imitate other people, but they imitate other people because they wanted to imitate other people. And they don't always want to imitate other people. So if there's somebody who you really look up to and that person starts skateboarding, then you're going to start thinking that skateboarding is cool. But if there's somebody who you think is really stupid and awful and they start skateboarding, then you're going to be, if anything, less likely to skateboard because now it's cringe. So yeah, foundation models can just ingest and duplicate human behavior, or at least human behavior as reflected in the text of the internet during pre-training, and they just get to clone all of these human behavioral tendencies. So that's not strictly true after post-training, but I think it's still like 99.999% true because most of the learning happens during pre-training. So foundation models have this sort of magical shortcut to sucking up human behavior and human cultural norms, which is, I think, the reason that people find it a lot easier to make foundation models to behave in ways that, at least superficially, and we can debate about whether it's deep or not, but at least superficially, Claude seems nice and ChatGPT seems nice and they seem to follow the rules. And if you ask them questions, they seem to give reasonable answers. if they're not jailbroken. I think it would be a lot harder to get anything remotely like that for brain like AGI. I think alignment is much harder and can go way more off the rails in the case of brain like AGI. And that's what I expect to happen.
And why is that?
Brain like AGI, everything it does because it wants to do it, because of the motivation system. There's no sucking up and regurgitating typical human behaviors. So you don't expect the brain like AGI to behave in typical human ways in typical human situations unless you have specifically somehow figured out a way to build that motivation system that leads to that. And I don't know how to do that, and I'm concerned that nobody else is going to figure it out either.
If someone listening to this wanted to work on brain like AGI safety, what's the best way to start?
Yeah, there's so many challenges. If we just focus on the technical challenges, there's the neuroscience projects that I was working on, which is to better understand how human social instincts work in the hypothalamus and brainstem. By the way, if you read Intro to Brain Like AGI Safety, which is a blog post series and also preprint, then the last post of it, or post 15, chapter 15, has a list of some unsolved problems that people can work on. I also list some things that are a little bit more like conventional machine learning or conventional computer science. I mean, it would be great to have, there's lots of stupid things that are going to come up sooner or later. Like, do we have good, secure reinforcement learning training environments that we can use for sandbox testing that have had a proper security audit against, an AI trying to break out of them? Probably not. A lot of these that are like really user friendly, such that people are actually going to use them. There's so many ways for us to shoot ourselves in the foot during this mad scramble to deploy future mad scramble to, where everybody's going to be trying to test and deploy brain like AGI as powerful as possible, as fast as possible. What can we do to lessen the frantic competitive race situation? I don't really know. What can we do to buy more time? I don't really know. I don't think anybody has great plans for any of these things, especially because I expect that the path from here to brain like AGI is people publishing stuff on GitHub and archive as opposed to bigger and bigger and bigger training runs. I expect that when we can make brain like AGI at all, we can make brain like AGI in a shockingly small amount of compute, like even a consumer GPU or two. Certainly, a university cluster would be plenty, because I don't think the brain uses that much compute, and it doesn't even use it very efficiently. And so nobody has a plan for governance that could survive in this low compute world that I'm anticipating. There are things that people can do on the margin. I think that would be helpful. What else? Yeah, just trying to think through the whole problem and what's going to go wrong and how to put the pieces together and come up with a good plan. There's a lot of work to do. I think I would love ambitious, creative people who can think carefully about problems, naughty problems that have lots of components, and try to find where everybody's dropping the ball and work there.
Safety work that's done in the current paradigm of foundation models, how relevant is that if the first AGI is going to be a brain like AGI?
I typically find it not super duper, at least technical safety stuff. Like I try to stay abreast of the literature. I tend not to find it super helpful for what I'm doing. Governance stuff is different. I find that, again, mostly, or maybe like helpful on the margin, but not very helpful. It would be nice, yeah. Like, so for example, if future companies collaborate on safety, I don't want the government to be, or I don't want them to think that maybe they're breaking antitrust law. And if the government could write a letter that says, obviously, AGI companies collaborating on safety is fine and not a breaking of antitrust law, then that would be a good thing. And whoever's working on that, I think that's, on the margin, a good thing that they should be working on. Again, I think, powerful AGI is going to require so little compute that it's going to be ubiquitous. But nevertheless, if it's ubiquitous, it would still be nice for governments to know where the data centers are. Yeah, or I guess I would prefer a world where the governments know where the data centers are than where they don't, and where they have at least some idea of what's going on in them. Maybe it doesn't make a huge difference, but on the margin, that still seems like marginally useful. It's not a fight that I would want to fight, but sure, why not?
It sounds like you're not very hopeful, just because if things are as you think they are, AGI will require not that much compute, so we can't perhaps track these giant training clusters that we might be able to track in a world in which AGI requires enormous amounts of compute. What developments would make you more hopeful?
Yeah, I think if somebody has a technical plan to make AGI that is sufficiently simultaneously sufficiently powerful to really move the needle on societal resilience and things like that, and also has the best interest of humanity and other things that we care about at heart, then having that technical plan in hand would be a great progress. It would also be great if more and more people were aware of that technical plan and sort of bought into it, especially people who are working on the many people who are working on brain like AGI as we speak. I'm not like that enthusiastic about outreach when I don't actually have the technical plan yet.
How could we ever be confident that we had the right technical plan in our hand, right? It's as I see it, it's bound to be a high stakes, fast moving situation in which we'll have some people, some group of people will have to make some decision about whether we feel like this is sufficiently safe. And that's even in the kind of positive, or in the positive situation in which we are even in which decision makers at a global scale are even thinking in these terms. But is there some way for us to know in advance whether the technical plan we have in our hands is actually going to work?
This is an important issue. I think it would be great to have, as a first step, a technical plan that is not obviously going to fail, which I think is the bar that we haven't even crossed that bar yet. Once we cross that bar, then we can start, like you said, to sort of hone in on how do we start to de-risk it? How do we do tests? Certainly, part of the technical plan should involve, sandbox testing and what unit tests are possible. Yeah, there's definitely I am very concerned and expecting that there's going to be a point of no return, a little bit akin to launching a space probe where if the antenna is pointing the wrong direction, then it's too late to fix it. So yeah, how do we know that something is safe? I don't know. I think that we should have some plan that seems like it might work, and then we can work bit by bit to try to flesh it out and to try to anticipate where it might go wrong and to have some theory based reasons to believe that those things won't go wrong, or things that are based on reasons as opposed to just hope.
There are a whole bunch of unknowns here, and there are things that we would like to know. There's a whole science of human motivation that it would be nice to have decades to kind of get a grip on. Are there any tactics for buying time that you think are useful? Is it useful to try to collaborate on pausing at a certain moment? Are there any ways to buy time that you find plausible?
The message that I want to project loud and clear is that more people should be working on brain like AGI safety who are not working on AGI safety at all, especially people who are trying to build brain like AGI. I do think that it's great, and I myself try to do lots of outreach to people in the AI and neuroscience communities who are either working on reinventing or reverse engineering algorithms that I think have the secret sauce that I think the brain has. It's a hard slog because they get paid. This is their life work. They're doing all this cool science and finding all these cool algorithms and beating benchmarks, whatever, in their toy models. And people don't tend to be receptive to the message that they're doing the exact wrong thing and they should instead be working on safety. Although I do like to emphasize that the technical safety problem is also this very interesting, fascinating technical problem with lots of discoveries yet to be made. And so they can still do cool neuro and or AI work, and still be on the right side of the aisle from my perspective. So that's where I spend most of my effort. I'm not that enthusiastic about the pause AI movement or governance efforts like that, because again, I think that the path from here to powerful AGI is going to be some new AI paradigm that's currently either non-existent or working in toy models, and that's going to happen without much compute. It's going to happen on GitHub and Archive and NeurIPS and stuff like that. It's not we're not bottlenecked on giant training runs. If anything, I think the giant training runs might be a distraction from actually powerful and dangerous AGI that I'm thinking about. But of course, I could be wrong, and I don't want to like make any very strong statements in case I'm wrong.
Yeah, I mean, I know a lot of people that will be very happy to see the large language model scaling paradigm kind of plateau for underlying technical reasons, so that we would have more time to work on safety. When will we know? Do you think when will we know whether that paradigm is plateauing?
I don't know. I mean, what was it? Dario Amodei has the most aggressive timelines that I've ever heard. He was like, we're going to have Nobel Prize winning inventions from autonomous AGIs in, what did he say, 2027 or something?
Late 2026 or early 2027. So
That's crazy. Yeah. So I think we will know quite soon whether Dario Amodei has been drinking too much Kool Aid or whether he knows important things that are not public information, or at least not that if he knows something that I don't. And then there's a lot of people who are, less aggressive than him. We'll find out. Certainly, things have progressed quite quickly since 2018. So as time goes on, we'll learn more and more about the capabilities of foundation models. And again, if somebody is working on the contingency that foundation models do in fact scale to powerful, dangerous AGI, then I'm happy for them to be doing that. I don't want to strongly discourage them from doing that because, what if I'm wrong? I don't know. I'm not. I've been wrong before, believe it or not, in my life.
Do you think AIs in the form that they currently have are either are useful in your work to help you in your research, or will be useful as researchers or as a research help, either as a tool or as an agent in trying to do the kind of safety work that you're doing?
I don't. I can't speak to the future. I think as of right now, I haven't gotten more than marginal help from the various foundation model service providers that I subscribe to. Yeah, I use them for sort of random little things that I could theoretically also Google, but maybe it would be take more time and be a little worse to Google them. I haven't successfully gotten like interesting conceptual ideas out of them so far.
All right. As the last question here, maybe you could paint us a picture of what success would look like for brain like AGI.
Oh gosh, I don't know, and it certainly shouldn't be up to me to decide what crazy sci-fi, whether and how we have this crazy sci-fi future. I think it's terrible that people are going to unilaterally welcome this new intelligent species onto our planet without necessarily knowing how to control it or make it care about humans. Yeah, what does the future look like? I don't know. I think that what I'm working on now, this technical problem of being able to sculpt AGI motivation such that it's not a callous indifference to human welfare, is a good thing to work on robustly across multiple scenarios. So I'm going to keep working on that. But, I've been thinking, this is actually a little bit part of what I've been doing in the past 6 months since writing Neuroscience of Human Social Instincts, a sketch. It's been actually a few years that I've really had my nose in the neuroscience books and haven't sort of caught up with the larger AGI safety and alignment, safe and beneficial AGI discourse. So I think there's a lot of disagreements between people in the field, and I don't feel like I fully understand where other people are coming from. And I've been trying to go through and hash that out. And I think I'm making some progress, but maybe in a couple months, I'll have a better answer to those kinds of questions than I do right now.
Stephen, thanks for joining me on the podcast.
Thanks for your invitation. It was a delight. Thank you.